All right, on this stuff today, what we're going to be doing is, again, we're going to go over 2 days with this stuff, but what we're going to do for this is we're going to be solving systems of nonlinear equations. What that means is that you're going to have, sometimes you might have a line, sometimes you might have a parabola, and you try to figure out what they share in common. Okay, so when you're looking at systems of nonlinear equations, the ones that you can have, that you're going to see is you're going to see a line, or you're going to see a quadratic, which is, again, what is a quadratic? What type of shape? A U, or a parabola. Okay, so those are the types that we're going to have. Now, there's a couple different scenarios that could end up happening. One scenario is if you have a quadratic with a line that do not intersect. Would they share any place in common then if they don't cross? No, they don't. Okay? If you get something like this where you have a line and a quadratic like that and they don't cross, or two lines that would be parallel, right? They don't cross, that would be something like no solution. Okay? If you see something like that to happen, that's going to be a no solution situation. If you see a quadratic, for instance, with a line that comes in and only hits it once, how many times or how many places do they share in common? One. They have one solution, which is a very, very real possibility where you could have one solution where it only hits it once. Okay? In geometry, we called that tangent when it came to a circle and a line, okay, where it came up and only hit it once. Then another scenario that you could have, especially with a parabola and a line, is if it hits it 2 times. So how many solutions would you have there? 2. And again, what you're trying to find is you're trying to figure out what they share in common. The ordered pairs that they have that they share in common. That's what you're trying to find. That's what you're going to do today. Okay? Now, what would happen though if I used a parabola with another parabola? Could I have something like that? Where 2 parabolas don't touch? How many solutions do you have there? None. Because it doesn't hit. What about this shape? How many times does it hit? Once. One solution. What if it's a parabola like that and then another parabola comes in here? How many times does it hit there? Twice. So this would be another example of 2 solutions. We're going to do this 2 different ways. I'm going to give you one of them or some of them by graphing, which means we're going to graph the two equations together. And then we're going to see how many times it hits and where they hit at. And the second way I'm going to show you is using substitution, which means no graphing. Okay? So just so that you guys understand, we're going to do this 2 ways. So the first equations that I'm going to give you, x squared minus 2x minus 1, and y equals negative 2x minus 1. Now before we go into any type of graphing situation, because that's what I want you to do first is the graph. When we're graphing with this, what you need to do is you need to make sure that both equations are y equals. Okay? And the reason for that is because you have calculators that graph as y equals. So are both of your equations as y equals? Yeah. Yes, they are. So from here, what we're going to do is we're going to graph both of them. Now, the first graph that I put up there, what kind of shape is that? Is it a line or a parabola? How'd you know it was a parabola? Because it's x squared. Good. Now, realistically, I could graph a number of different ways, but how are you going to graph it if I don't specify how to graph it? Type it in your calculator. That's probably what I would do too. What's the second type of graph? It's a line, right? So what you're going to do on your graphing calculators is you're going to hit on, and then you're going to go into y equals. Those are my buttons I'm going to push. Then, under y1, you're going to type x squared minus 2x minus 1. Once you've typed that in there, go down to y2, and type in negative 2x minus 1. How do you type the negative sign? The negative button down by the decimal, or the enter key, right? Okay? Then, from there, I want you to hit graph. So once you've typed that in, thanks, Allie, I appreciate it. I see a picture on Allie's that looks something like this. That was the parabola. And then I see a line that comes in here, and it looks like it hits it like that. About like that? Or close to it? Okay, now, when you're graphing these, or when you're doing these, what I want you to do is make sure you solve for y. Then you're going to plug in, then you're going to draw a rough sketch of what you see. How many times does it hit? Looks like once? Okay, now, if you're using graph paper, it might cross right at a certain ordered pair. What if you're not using graph paper and it doesn't hit at a certain ordered pair? Then you're not going to know what that number is, are you? If you're not using graph paper, are you going to be very accurate? No, you're not. What if it goes right in the middle? How do you know if it's like 0.5 or 0.4? Do you know? No, you don't. But your calculator does. So after you've typed everything in, here's the next sequence that you need to figure out in order to actually get the answer and have the calculator tell you what to do. Now you're going to hit second and the trace button. Then you're going to go down to option number 5. What does number 5 say? Intersect. That's what we're trying to figure out for this, is where they intersect. Okay? So when you run option number 5, or the intersect feature, it's going to ask you 3 questions, very similar to when we did zeros. It's going to ask you, first of all, if you're on the first curve, which first curve means, is it on the first equation you typed in? Yes or no? When you do this, when it says first curve, so go second, and the trace button, down to number 5. Now it's asking first curve. Abby, is it on the first curve? No. How did you know? You don't know? It just looks like it. Look at the top of your screens for those of you with TIs. Does it say the equation that you typed in? Does it say the equation you typed in, the first one? Yeah. Then you know you're on the first curve for sure. So if you're on that first curve, hit enter. Now it's going to ask you, are you on the second curve? Which means, is it on the second one that you typed in? Yes or no? If you are, hit enter. Now I'll ask you, would you like to make a guess? No, just hit enter. And what comes up? X equals what?
0.
So the point at which they cross at, or the point at which they share in common, is 0 and negative 1. Did anybody else get something different? Tamara, what did you get? Okay, now Tamara got something a little bit different, but she is the same answer. One of the things about these TIs, just so that you guys know, when they get programmed at the company, they are just a little bit different. Everybody's is a little bit different. Some of you got right on 0, negative 1. Tamara got 6.8216 e to the negative 7, and y equals negative 1.000001. Okay? So what happened was, her calculator does not have a particular pixel for 0, negative 1. So it put it on the closest pixel possible. That first number that I read to you that one that had e to the negative 7, okay, that's the same thing as putting 1, 2, 3, 4, 5, 6 zeros before the rest of the number, whatever that was. Because I hit a button and it already changed it. That's 0. Okay? Here's where this is going to get screwed up for some of you. Some of you would not look past that and would not see the E thing. Whenever you see an E, okay, and what I was talking about with her calculator, it said 6 point blah, 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 e to the negative 7. This right here means that's 0. That's 6 zeros in front of that 6. They just couldn't put a pixel right on it. Same thing with the wise guy. The wise guy had this. That's negative 1. Okay? It just couldn't put a pixel directly on 0, negative 1 for hers. When it came up on Abby's, it came up exactly at 0 and negative 1. Because Abby's was programmed a little bit different than Tamara's, even though it's the same calculator. But what happens to most people, when they do this one especially, they say it's 6.03 or something like that, and negative 1. That did not cross at 6 point something. It did not go 6 places over. Bless you, Abby.
Thank you.
You need to have some number sense when it comes to that. Look for the E. If you see e to the negative anything, that's usually 0. Okay? So I'm glad that came up. Thank you, sir. Was that the only place that it crossed? Looks like it only hits it once, right? Okay, good. What if it hit it twice? Then you do it again. And when you do it again, you move the cursor closer to whatever one you want to find. Okay? So, let me give you another one. X squared plus x minus y equals negative 1. X plus y equals 4. Okay? If I was doing this problem and I want to use my calculator, what's the first thing that you have to do? You got to set it equal to y. So as you're writing it down, start thinking about how we're going to get it equal to y in the first one. Anybody have any suggestions? Add y. Okay. If I add a y over, what do I do with the 1? Add 1 to the other side. So I end up with x squared plus x plus 1 equals y. Did I get it equal to y? Yes, good job. Now how do I do the next one? Subtract x. So y equals, can I have it as negative x plus 4, or could I have it as 4 plus or minus x? Either way, right? Does it matter which one's or what order it goes in? No, the calculator understands the order of operations, and commutative property is in effect, so therefore it doesn't matter if you put it like this or if you put it as negative x plus 4. So, do we have them equal to y? Yes. Now, put the first one in the y1, the second one into y2. And looking over Hunter's shoulder, I have something that comes in like that and goes out like that. That's his parabola he had. And then I have a line that comes in here like so. Anybody else get a shape or a picture that looked like that? Quite a few of you? Okay. How many times does this cross? Twice. Which means how many answers are you going to have? 2. So you're going to have 1 for this one and 1 for this one. So, going with what I just went through and put on there, I want you to hit second, trace, option number 5. And when you do that, the cursor should be somewhere about here, I'm guessing, when it's saying first curve, right? So hit enter. And then the second curve, we'll put it here. Hit enter. Guess. Yeah, just tell me the answer. And I'm guessing it gave you the one it was closest to. What was the ordered pair that they gave you? 1 and 3? Is that the only answer that it is? No. It gave you this point right there, didn't it? Okay? When you hit second trace in option 5, if you don't move the cursor whatsoever with your calculator, it's going to give you the closest one. That's the one it gave you. Okay? Now to get the second ordered pair, hit second trace again. Option 5 again. But this time, when it says first curve, it's blinking right around here, isn't it? How are you going to move the thing closer to this one? Which arrow specifically? The left arrow. So you want a left arrow enough so that you're closer to this ordered pair. You can hit it and hold it down and it will slide across there. Once you get closer to that ordered pair, hit enter, enter, enter. And what would you get for the other point? Negative 3, 7. I wrote them as ordered pairs. So therefore, the first one was 1, 3, and the second one was negative 3, 7. What do you think? Again, once you type it in, second, trace, option 5, and then you go with first curve, second curve, guess, and just answer. And then if you need another one, you move the cursor closer in the next one. What if there would have been 3? Then I would have did it again. You're never going to have one that has 3 this year, but maybe in college algebra you might. Okay? Then, what about this type? On the left one, how do I get y by itself? Add y to both sides and add 2 to both sides? Like it. 2x squared minus 5x plus 2 equals 0. Or equals y, I mean. Sorry. And how do I get y by itself on the right side? Subtract x squared, subtract 2x. Now, the reason why I'm moving that over there is because remember, when you have this going into your calculator, is it y or is it negative y? It's y, which means positive y. So if you were one of those people that subtracted the y over, then you would have to divide everything by a negative 1. Either way, works out the same. What kind of shapes am I going to be looking at? Both of them? Yep. Okay. So graph them. And what do you see? Looking at Sierras, I see one that comes in here like so. And one that comes up here like so. Something similar to that? Is that what you guys see roughly? Okay, now, how many times do they cross?
None.
They don't. So therefore, what should be my answer?
No solution.
No solution. Just to verify it, what I want you to do is I still want you to go second trace. Option 5. And run it on there and see what they give you for an answer. Okay? Hunter already got it, and it said error, no sign change. Error, no sign change on your calculator means they didn't cross. Okay? That's what that meant. When it comes up as error, no sign change, it did not cross. Some of the pictures that you're going to see might look like it hits, but it really doesn't. So therefore, running that is still, if you can obviously see that they're not going to cross, then you wouldn't necessarily have to do it. However, there are some that are really, really close that it looks like they touch, but when you run it, it says error, no sign change. So just so that you have seen that before, that's what it's going to show. What do you guys think about the graphing method? Not too bad? Okay, the next type that we're going to do is using what they call substitution. Do you know what the word substitution means?
You could, like you replace it with something else.
You kind of do?
It's you replace. I don't know, like how to say what I don't know. You like replace it with something.
Replace it with something else, right? Okay, do we use substitution in our daily lives? Not just math. Have you ever went somewhere and had something to eat and said, you know what, I don't want fries, I would like something like a bowl of soup or something with it instead? You're using substitution, right? In coaching, I use substitution all the time. When the hockey players aren't doing exactly what I want them to do, I take them out and put somebody in there in its place. Or as a goalie coach, if my goalie is doing really poorly, we take them out and then we put somebody in its place. We use substitution in basketball. Those of you who are basketball players or soccer players, isn't that in the terminology in when you sub in? That's in there already. So, when using substitution, okay, here's what you'd have to do. I'm going to give you steps for solving this. What you do for substitution, first of all, is solve one equation for one of the variables. Notice I wasn't specific. I did not say solve for y or solve for x. I don't care which one you solve for. When you're using substitution, it does not matter what one you solve for. Now what you're going to do once you solve it is you're going to plug solved equation into the other equation for that letter. Step 3. You're going to solve for the letter that's left. And here's what I mean by that. If I solve for y and I plug the stuff in for y, then the only letter that's left over is x. If I solve it for x and put it in there, and the only letter that's left over is y. So you're going to solve for whatever letter is in the problem. And that's what's left over. Then step 4, the last step, you plug answer back in to find other letter. Those are my 4 steps I'm going to take when I solve by substitution. Substitution with nonlinear or linear even. If we had linear stuff later on, I'm doing the same thing. So, everybody got that? Okay, so if I have a problem like x squared plus 3x plus y equals 0. And I have 2x plus y equals 5. And I want you to use substitution this time. How do I solve for by substitution? Step 1, solve one of the equations for one of the letters. So what you have to decide, I can't make this decision for you. I'm sorry, I can't decide everything in your lives. What I need to know from you guys is, first of all, what equation do you want to solve for? And 2, what letter? You want to solve the second one for what letter? For the y? Me too. But why did I want to do it that way instead of a different letter? Why did you guys want to solve for y? Because it's alone. What do you mean by alone? It doesn't have a number with it or a coefficient with it. Okay, a coefficient is the number in front of a letter. So when I do that, when I'm solving for y, I would have solved it. I would have done the second one too. I would have got y by its lonesome. So minus 2x to both sides. So I get y equals 5 minus 2x. Did you do step 1 with that? Yes, you did. Step 2, you're going to take solved equation and you're going to plug it into the other equation for that letter. So x squared plus 3x plus 5 minus 2x equals 0. The reason why I put it in color is I wanted you to see, I took the y out, I threw it away for a second, and put something in its place. I substituted. I took the fries out and replaced it with sweet potato fries. Okay? That's what I do. Now, from here, you need to solve for the letter that's left over. So we need to solve for x. That's what it says. Oh, shoot, this one's an x squared. That means we either have to do completing the square, factoring, or quadratic formula. Yucky. But first, before you do that, let's get everything together. What's 3x minus 2x? How do I solve this? Which way do you want me to solve it? Factoring, quadratic formula? Quadratic formula, okay. What number is in the B position? Good. Plus or minus? 1 squared minus 4 times. What's in the A position? What's in the C? A negative with a positive 1 makes that a negative 1 plus or minus the square root of. What's 1 squared? What's negative 4 times 1 times 5? What's 1 minus 20? Negative 19. Wah, wah, wah. Negative 19 is not real, is it? Which means what? You can't, they don't cross. Okay, so if I were to use graphing instead, guess what would have happened? They would have had a line with a parabola that don't cross each other. So therefore, what's my answer? No solution. Now, what would have happened though if it would have been a positive? Then we would have kept going. The ones that I've noticed in here with this assignment, just so that you guys know, they come out at perfect whole numbers for you. It's really nice. They don't always do that, but for your assignment, they do. So for that particular one, it would have been like the square root of 25 or something, or square root of 16 or something like that, where it would have came out perfectly. Do you want to do another substitution one? Are you sure? Have you done it before? But with linear ones, not this type. Okay? So, if you look on page 136, on the first set, it says solve the system by graphing, which means graph it, and identify using the intersection feature on your calculator, see where they cross. Then 11 through 14 say solve the system of nonlinear equations using the graph. It already gives you the picture. You don't have to draw it yourself. Then on 15 through 24, it says solve the system by substitution.